Okay, so this lesson today is on a concept called a radian, and a radian is a degree of measure that we're going to use within a circle. So just to kind of set it up, let's talk a little bit about, review a little bit about what we know about circles. So if I look at this circle right here, I know that the area of a circle is pi r squared, and I know that the circumference of a circle is 2 pi r. Let's see, I know that a circle has 360 degrees, and if we look at this circle has a radius of 1, and I'm just going to say that my unit here is an inch, so unit of 1 inch. So now I want to set this up and get away from this thinking of 360 degrees. So I have this rubber band that I cut up, and I have this marked here with a radius of 1. And what I'm going to do is I'm going to go all the way around this circle, and I'm going to mark the radius as I go around this circle. Okay, so now that I have this marked all the way around, I'm going to look at this as the x-axis and bring this out a little bit. And I'm going to go ahead and count how many times I went around. So here is 1 radius, 2, 3, 4, 5, 6. But this distance right in here is not a full length. It's not a full radius. So if I just estimate this a little bit, I'm going to say that this is about 1/4 of a length of that rubber band, which is about 0.25 of an inch. Okay, so what I've gone around 6.25 times. So now let's go down here to our circumference formula. And the circumference formula is 2 pi r. And with this particular problem, we know that r equals 1. So for this problem, I have 2 pi. My radius is 1 inch, which is 2 pi. So now let's talk about what this really looks like. If I plug this into my calculator, 2 times pi, it's 6.283. So this distance is 6.283 inches, right? So if I compare going all the way around my circle with my string to a calculated circumference of 1, I see that these values are pretty close, which makes sense because this was just an estimate anyway. So now I want to look at it a little bit differently, and from the center of my circle, I'm going to draw all of these radius to wherever it met up on the outside of my circle. Okay, so here's what I have. And what I know now is that this is a radius of 1, and this is a radius of 1. And because I used the string, I know that this is a radius of 1. And I can go to any of these big pi wedges, and I know that anywhere around there, I have a radius of 1. So what this means is, as I go around, if this is 1, and this is 1, and this is 1, then this gives me 1 radian. So now I have this angle measurement of 1 radian, which means that this angle measurement here would also be 1 radian. So as we go around, we see that we have 6 radians, but then we have this little part here, this little tiny one that didn't make. And so this guy has to be 0.283 radians, and that comes from this part of my formula, my 0.283. So what we've created is we've created this conversion ratio, and we know that if we go all the way around the circle, when we have a circle with a radius of 1, then it's the same as 2 pi. So think of this, if we have 360 degrees, which is all the way around the circle, 360 degrees in a circle, this is the same as 2 pi. So we can create these conversion ratios of 360 degrees to 2 pi, or 2 pi over 360 degrees. And this is the conversion ratio between degrees and radians. And you know, another way that you can look at this, you did this in chemistry all the time, if you're just doing conversions, you have the same as 12 inches over 1 foot, or you can write this as 1 foot over 12 inches. And so depending on what you're looking to solve, you could write this proportion or this ratio either way you need to. All right, so now let's look at this bigger circle. So now we have a circle, and I don't know, let's just say that this is 2 inches. And if I measured this distance and I went all the way around the circle here, and I said that this distance here was also 2 inches, and this distance here was also 2 inches, and I went all the way around, and I didn't measure this, of course, but let's just say that this is 2 inches, and this is 2 inches. If I go all the way around, what I'm going to find is that my circumference of this circle is 6.283, which is the same as 2 pi, times my radius of r, and in this problem, my radius of r is 2. And so I've got this radius here of times 2. So this is how I would come up with my calculation. Now, here's the thing to remember. Here's my r, and here's my r, and here's my r. So this angle here is not 2 radians. This is still 1 radian. And when I add it to this angle that has the same, now this distance right here, let me make this a little bit bigger. This distance right here is 2 radians. And if I had the next one over here, this distance right here would be 3 radians. So as we have a radius and an arc length, this is my arc length, that are all equal to 2 inches, or that my radius, my arc length, and my radius are all the same, then that gives me 1 radian. So as I increase around the circle, if everything is the same, then I would come up with 1 radian, 2 radians, 3 radians. And when I get all the way around, like I did with my little circle here, I end up with 6.283 radians in a circle. So what is the equivalent of a radian in degrees? So 1 radian is about 57.2958 degrees. And this is not important because you're going to do your calculations off of this conversion factor of 360 to 2 pi. And that way you'll always have exactly what your radian is to degrees.